Hello. Hello. Hello, everyone. Hello. Am I audible? Hello.
Yes, sir. Good evening. Audible, sir.
Okay. The class will be started at the 7:45. Here is 7:34. So we will. I'm online. If you have any question, please ask. Otherwise, we will start at 7:45 because some people are coming. Okay.
Sir, excuse me, sir. Yesterday you posted all the scores and all,
Mhm.
so we couldn't able to practice actually. So finally, after all the scores and all, so can you do one demo, sir? Totally from starting from uploading the syntax and up to making the coordinates. So just only one time you can do all together, sir.
Yes.
So we Okay, sir. It is very difficult for us to enter the code. If any mistakes are coming in, we are not getting any plot and all. So exactly what we have to do, what are the steps? Steps already you have given, but how to enter that, we don't know. How when to run after the typing the syntax and all, we are not aware of that, sir.
Okay, we will do.
Okay, sir.
Yes, yes,
So
we will do. Don't worry about these things. Yes, Tomorrow
Okay.
the is the last class for this session,
Okay,
so we
sir.
will do for this.
Okay, sir. Thank you.
Speaker sir, kindly share the slide one of your PPT, please.
Okay, sir.
Dear participants, kindly introduce yourself through chat box, your name, designation, department, college, institute name, city name, etc. I repeat, dear participants, kindly introduce yourself through chat box, your name, designation, department, college or institute name, city name, etc.
Is it my screen is visible? Hello. Is it my screen is visible?
Yes, sir, visible, sir.
Okay. Okay. Someone asked me yesterday, what is the if we are doing for some if someone asked me and suppose that we are interested in the India, so we are using here IND code. But what is the code for other country? So I have written for code for all uh, uh, country of the world, and you can run this. Then definitely you will get the data and plot these things and do your uh, operation on this script. So first start with R Studio. Just search in R Studio. Okay. Now uh, activate these packages and activate these packages through library function. Okay, that has been activated. Now here first we will plot India. IND. Okay. Okay, now data is downloaded for IND. Okay, it has been downloaded. Now use the command plot, simply plot, and use these data and run this. See polygons, its extent of the India is from here to here and all over uh, its district state has been given. When you're using the plot, then this will come here. It will take a few minutes, don't worry. Okay, now next we are going to plot in, if we code AFG for Afghanistan. Now here write shift AFG. Now AFG data is downloading. It is in process. Now it has been downloaded. So the extent of the Afghanistan, these are the state, districts, whatever they are. Now going to plot the Afghanistan. See, this is the map of the Afghanistan. Similar way, if you need, suppose that I'm randomly check for Brazil, BRA. So for BRA, data has been going to download it. Okay, now plot the GM for this one, Brazil. This will take few minutes. Okay, don't worry. It is going on. I think Brazil is very big country. So this is the Brazil. Okay. So this is the way for uh, plotting these things. Now, next things I will tell you how to export these save file as a .shp function. For this, I'm going to make a separate this one folder name shp. Okay, name given is shp. Now going for our script. I just change its uh, working directory folder. For this, use the set wd, and working directory is my working directory is shp. Just copy this one and go to the r, make it double. Sorry, there is okay. It should be in double inverted comma. Okay, now it has been set. The data already we have um, downloaded. Now our aim is to this. The data name is the GADM data. Give its name here GADM. So it is a history. So we are using a DSN. Give the name of this. Name is your whatever name. Its name is uh, give its name already GADM. Don't worry. It's for Afghanistan and whatever. Driver is S3. Could not find function write OCR. So for this we have to get the function OCR. So this will be in this library. So first activate this library. Okay, now it has been activated. Now I think this will work. Mm, right, OCR. Now it is okay. Ethernet data OCR DM data DSN dot layer DN driver is saved. And okay, then what will you do? Okay. Now it is value character type 1 scado is a type underscore 1. So we are use the dollar function, give its name L. Okay, and activate for type underscore 1. So L for escado it is whatever. Okay, there is a something. So plot the escado. There is name underscore 1. Okay, check for this. This will work. Okay, that is the state of this Brazil. Oh, I should give its layer name. Label name, that is label. This file not exist. For level 1 this should be exist. You have to search for this. Maybe okay, level 1 for this will be exist. Now this is the why they said not showing. Anyway, just I'm going to plot this one. Do for I'm doing for the India. If you have this thing, then I will show you later. Okay. Now next is what will you do? Just suppose that I'm interested in the ballistics. So we have okay, and now it is Balia is here. Mhm. Now going for this. Yeah. Okay. Okay, plot N2. This is India. Just I'm going to export this save file. Uh, okay, it has been done. Next is this. Okay, now using this, otherwise we will do this one later. I will check why it is not exporting this. OGR function. This is my final data. Use this. Give it same name. Layer is ZADM. Okay. I remove this one. Okay, we will check it later why this is happening. I have to check which function is missing in this. Driver history is not working. So today is the very important things. That's the thing is buffer analysis. Okay, point proximity buffer analysis. What is the buffer? We will see. Okay, so point proximity buffers. What is the buffer? It's a very important topic in GIS. In GIS, a buffer is a zone created around a geographic features like a point, line, or area. Think of it drawing a circle or other shapes around something with a specific radius. For example, if you have a school location on a map.
Sir, good evening, sir. Excuse me, sir.
Yes.
Sir, could you please increase the Word file size? That is plus 100% is there. Could it be increased to some 150 or something like that so that it could be visible in our screen?
Okay, I'm
Yeah, thank you, sir.
now it is visible. Now it is visible.
Yes, sir. Yes, sir. Correct, sir. Yes, sir. Thank you very much, sir. Thank you, sir.
Okay, now the important topic. The previous our aim is to exporting the save file because .ssp extension with some its extension file .shx.prg. What is this? But it cannot be done due to some missing function in R. I have to check whether it is some libraries are required. Don't worry, I will check this one. But here the most important topic today topic is a point proximity buffer analysis. So in GIS, a buffer zone created around a geographic feature like a point, line, or area. Think of it drawing a circle or other shape around something with a specific radius. For example, if you have a school location on a map, a 1 kilometer buffer would show the area within 1 kilometer of the school. Why use buffer in GIS? Buffer are used to analyze proximity, how close something is to a feature. They help answer questions like which homes are within 500 meters of a hospital, how many trees are within 100 meters of a river, or events like car breaks means car thefts in cluster around a specific location. In simple words, a buffer is like a drawing a safety zone or influence area around a point, line, or area on the map. It helps us understand relationship between location and their surroundings. Setting up the data, we will need to load required packages. You should have already installed these packages in prior labs or class. So you need to run install packages in what these packages I will show you. So in detail way, what is a buffer in GIS? A buffer in GIS is a boundary created around a specific location such as a point, line, or area to show the surrounding space within a set distance. Think of it as a safety zone or an influence area. So simple example, imagine you have a school marked on a map. If you create a 1 kilometer buffer, it will show you the area that falls within 1 kilometer of the school. This will be more clear. I will show you with the pen. Uh, Suppose that this is your a school. So this is your a very big area. But in 1 kilometer, I want to point out the area of the car theft, that is car breaks, where uh, most of the car is stealing. And the second thing is that here is some uh, alcohol. Suppose that because near to the schools you cannot open any alcohol and or intoxic or shop here. So we want to mark out this, and suppose a crowd area we want to mark out, but we don't know how much area is this covered. So I fixed it 1 kilometer. So buffer will analyze 1 kilometer area and catch the all our marked things. So this is the work of the buffer, and that's called the proximity, also called the proximity analysis. So in simple example, imagine you have a school marked on a map. If you create 1 kilometer buffer, it will show you the area that falls within 1 kilometer of the school. Buffer, why buffer is important? Buffer help us analyze how close something is another feature. They are useful for answering question like home near a hospital, which houses are within 500 meters of a hospital, environment impact, how many trees are within 100 meters of a river, even clustering are incidents like car breaks happening close to the certain location, example parking lots, if the parking lots are available. So the necessary packages in for the buffer we have already seen library SF, library TTBus, library TMAP. We will then bring in for buffer analysis four types of the data. The first is a file of San Francisco census tracts. Second is CSP containing car brakes. This will be more clear here. I know, I want to uh, explain you these. Okay, this is the code explanation. Okay, let's see from here. Four type of data. The first is a shape of file of a San Francisco sensor tracks, a CSV containing car brakes. Second, car brakes means car theft data. How many cars are stealing in that area? Third is a CSV file of a San Francisco elementary school where the location of the schools has given. For a list of active business in San Francisco. So active business area, market area in these uh, near to the in this city. So these are the four file, and we will analyze this for buffer analysis. I These files are uploaded already uploaded in the GitHub, so we can directly fetch with a driver through R, and which packages are required for fetching these through GitHub. GitHub is just like a online. You can say that online is space where you make a your account and keep the data and all things and give the direct access from the GitHub. So the code for bringing in the files and cleaning them are below. We will not go through each line of code in detail because we have covered all of these operation and function. We have embedded comments with the code briefly explaining what each chunk is doing, but these things. So first, download the zip file containing San Francisco City tax safe file, tract safe file. For this, set your path, and this is the URL, and just copy and paste on your this Google or things, and then automatically downloading started. But we will fetch this through uh, R Studio. So unzip these things, and next is that these are the code downloading code for this all. So now next, after the downloading all these type of these four type of the data, next is creating buffers. The first task is to visually inspect the car brakes around elementary school. That is, do we see clustering of point around the school? We'll answer this question by creating a buffer around schools. The size of the buffer depends on the city. You are examine the context of the if you have any during the suppose that you are going to survey for the school, so that question will then arise. In this case, let's assume we 150-meter buffers are useful. So which is the average size of a sensor city block? That's depends on the C file. So we use the SF function st buffer to create a buffer. The required argument are so you buff these things. So these are the code. We will later explain what these are code. The next operation after the school we are mapping in located in the bottom city. This one, this Alado Elementary School, 150 meters. Take the buffer, so it's a circle buffer. So this will be more clear. Don't worry about this. When we will run and see the result, then this will be more clear. If you zoom in this figure, then already zoom in. So you will see that the school is right at the middle of the buffer. At the middle of the buffer, the radius of the buffer is 150 meter, and we find that there are four breaks in located within the blocks. So one, two, three, four. These are the our breaks. These are the our this thing. So I have to consider about this thing. One operation we can do using these buffers is to keep just the break-ins located within the buffers. We do this by using a function, that is st intersect function. So these are the code. We are not going in the code. We will explain it later. So the object elem.buff.break is a point SF object containing all breaks in located within 150 meters of elementary school. One things we can do this. These data is at map. So fresh this in a map. After then what we will do? We will do make a static map and present it to the San Francisco Police Department to visually show how breaks map on elementary school. So do these are the coding part, and we will understand this later. So do breaks in cluster around a certain business. So after the buffering, now analysis part has been started. The first question is, do break-ins cluster around a certain business? A map is fine, but when we will create a map, this will be fine. You will see, but we will want to add some numerical summaries to get a better idea of where break-ins cluster. So in this section, we will answer the question, do car brakes cluster around a certain types of business? We can do this by creating a buffers of a certain distance around each business and counting the number of breaks ins inside the buffer. The key variable in this data set in the Nexo code description, which provides a broad description of the business. So this is the let's create 150-meter buffers around each business location. So we will see it in a practical part. After doing these things, the next work is we will count the number of break-ins located within the each buffer. We will do this for all business in our data set. Remember that bus.buff is a polygon, and it is a polygon feature containing the number of breaks inside the buffer is a point in a polygon's operation. The aggregate function will have to join the object we get from the aggregate back to the buffer. So these are the things coding part, and what the meaning of this code we will explain it later. So doing these things, we can then use summarize to find the mean number of a car breaks in that occur within the 150 uh, meters of each business type. So now come to the coding part, and we will understand each type of the each line of the code. So load libraries. Library is first SF. The SF library is working with the spatial data in an R. It helps handle geospatial format like C file, transform coordinate system, and performs spatial analysis. Library second is a tidyverse package. The tidyverse is a collection of packages like DP, LYR, data manipulation, and ggplot2, data visualization. It simplifies tasks like filtering, joining, or plotting datasets. Library tmap. The tmap packages is for thematic mapping. It helps us layer spatial data. Style maps, example color, shapes, and add features like titles, scale bars, and legends. Now next is setting a working directory. If you have a working directory, just give the path of this. Now set wd is a well for the setting the working directory, where the program will look for the all files and save outputs. Here it points the buff is your folder, that is the folder. You can choose any folder which you want to make on your system. So So downloading and extracting data, downloading dot file URL. So HTTPS, these things. So there are four types of the data, and for downloading, first give the use the function this, and the download dot file, and downloads a zip file from the given URL and saves it locally as a sf underscore track dot zip. The zip file contains a C file, a standard format for spatial data of San Francisco tracks. Unzip zip file is equal to sf underscore tracks.zip. Unzip extract the contents of the zip file into the working directory. The extracted file include sf underscore track.ssp, the main save file used in spatial analysis. Reading the save file, sf.tracks is a st underscore read, sf underscore tracks.ssp, st underscore read the save file sttracks.ssp into R as a simple feature object. Simple feature SF, a data type of handling spatial data, points, lines, polygon with associated attributes. The results sf.tracks contains both geometry, tracks boundaries, and data like population. Reprojecting data sf.tracks.utm, sf st underscore transform, sf.tracks cr is equal to pro g is equal to utm plus zone is equal to 10, and that's zone. You have already told the how to the define the projection, what is the epsg and what is w. So these are the things. So the function st underscore transform for the reproject spatial data into a new coordinate reference system. So CRS is ensure accurate distance and area calculation. Here be data is transferred to UTM zone 10, suitable for the measurement in San Francisco city. Now second is a CSV datasets. So breaks .df and read underscore CSV for downloading CSV data, handling with the CSV this function, and is the URL for this. Read.csv is roads, downloads and loads a CSV file for car brakes, and car underscore break in .csv. Break.df is a data frame containing data like coordinates xy and time stamp of incident. So now next is function is elm and .df, make a variable and use the function read underscore csv for handling csv data. Loads a csv file for elementary school .csv, that's a data. And elm.df includes a data like schools names, latitude and longitude. So it's a variable contain these things, school names, latitude and longitude. Now next is the bus.df, and this is the URL, and this is also a CSV file. For handling CSV file we will use read underscore CSV. Download a CSV file of San Francisco business sf underscore business under 2018.csv. So, and then the bus.df include business name, location and types. Covering data to a special format, break.sf st as sf break of chords. Here the xy is a latitude longitude, and crs are the same as the tracks. So sf st underscore as underscore sf converts the car brakes in data frame break.df into a special object. Code is specify columns xy as the coordinate. CRS assign the same coordinate system as sf.tracks element .sf st as sf element.df codes to see longitude and latitude. CRS is st underscore crs st.tracks bus.sf st as sf bus.df codes is equal to latitude, longitude and latitude. CRS is equal to st underscore cr, and this things converts school elm dot and business bus dot df functions, which is a csv file, into a special object using their latitude and longitude. So reprojecting the data to UTM. So for this, reprojecting car brakes into UTM zone 10 for accurate distance calculation with the help of this code. Similarly, reprojects school and business to the same CRS. So coordinate reference system must be same for all four type of the data. So filtering, next is the filter work with data with boundaries. Use this line code of the line. So function st underscore intersect check which car brakes is points overlap with San Francisco tracks. The results are sub dot set. These are the results saved in this filter result. Sub dot int is a list showing a matches between the points and polygons. That's the filter data. So next code is filter the car breaks into the keep only those within the San Francisco boundaries. So similar filtering step by apply to the business. So creating buffer around a school, and we will buffer around a 150 meter. So we will make a function elm.bf st underscore buffer, and these are in function st underscore buffer creates a 150-meter buffer zone around each school. The buffer is a circular area for analyzing data. Example, nearby car breaks in, visualizing data exp map, utm turn polygon tm above, and these are the visualizing map code for this we will see later. And in this the function use st.tracks.utm San Francisco tracks boundaries, which is a variable in which we have already defined this thing school buffer zones, and that is in red semi transparent. And the breaks sf.utm car breaks in points black dot, that is stealing zone where the most of the car thefts are available. So adding map elements, time scale bar, here the time scale bar adds a scale bar for distance difference. tm underscore compass adds a compass to show map orientation. tm underscore layout sets the map detail and adjusts layout. What is a buffer in GIS? A buffer is a zone created around a point, line, or area to define a certain distance from that features. A point buffer, a circle around a school showing a 1 kilometer radius. A line buffer, a zone around a river within 100 meters. And an area buffer, a region around a park showing how far it extends. Buffer help answer help answer like how close a certain homes to a hospital, how many breaks in happen near the school, are trees within a specific distance of a river. So purpose of this analysis, the first is a proximity analysis, understand how near or far objects are to each other. Environmental studies, examining impacts around rivers, forest or urban zones. Crime analysis, finding cluster of events like theft near certain location. What is happening in the code? The code works with real data for San Francisco to load different dataset. School breaks in business census area. Transform this data to make it compatible for a special analysis. Create buffer around a specific location. School business. Analyze patterns like counting breaks near school or business. So this is the way for loading these things and importing. Here the data includes census tracts data, boundaries that divides San Francisco data, small region, car breaks, location of the car theft data, elementary school, coordinates of school, business, location of the active business. So these are the codes and how we will analyze this. I have already explained the whole of the code. So now we are going to run this course. Conclude this code demonstrates how GIS buffer help analyze spatial relationship. Break-ins near schools are mapped and counted. Breaks in near business are mapped for clustering pattern. So first, what will you do? First, make a folder. So this is my working directory folder. Now I make a uh,
Excuse me, sir.
yes.
Sir, if you share these all codes, then even we can do along with you, sir.
Sure. I will share. I will share. Okay.
Sir, if you share at the ending of the class, so
Hmm.
we can't do along with you, sir. If you share before the class, so we can do along with you.
Okay, then you have to message me now. Please also send the today's codes. Anyway, I will send these things. Just don't worry. I'm going to just have you
Okay, sir.
plotted these R and R Studio have you installed?
Yes, sir. I have done.
Okay, I'm just going to the Okay, I have shared the code through WhatsApp and chat box. So
Thank you, sir.
now load this library and going to download all these type of the data, all four type of the data, and what these types I have already told you. So my folder name is this one, shp. It has been downloaded, and now I'm going to unzip this one. Now run this. Now next is type of this type of the data download. Now next download business type, make using central track CRS. Now use the buffer function one at 150 meter after downloading this. Okay, now buffer has been done. Now so map will plot it, and you will see this will come. Just wait. Now it has been come. Now zoom this one. Okay, add the some open street map or uh, this map is good. And now this one. Okay, when this is a save file of the San Francisco city. Okay, this is a save file of San Francisco city. So in this all type of the data has been plotted after the buffering this one. Now we will filter the data for uh, these in this near 150 meter of this school. Now see, these are the data. That's it, and data for the sftracks.utm breaks. These are the breaks where the red, what is the for the red, where the active business area, and the black dot is and the here the black dot is for your that's one where the car thefts area, car breaks area. So this one, the red area, and dot this one. Now at 150 meter buffer again do and filter for all proximity. Okay, it's going on because it's a code is running. Here the red line is red mark is showing. When this will stop, and the code will stop. Okay, this is taking some time. I'm stop here. Okay, now this see the tabular for the buffer. So around the 150 meter, see the all ownership name. That's the active business name. So these are things are when you will export this in Excel file, then you will find. So do and try to understand these things. I have provided the code data and explain these things and do these things. And if you have any question, please ask. Hello, hello.
Sir, if I get couldn't not find the function st transform means like what kind of the errors that I can't find?
Please share in chat box. Share in chat box. I will show the error.
Oh, okay, sir.
Sir, good evening, sir.
Yes, good evening.
Sir, for tomorrow's class, could you train us using all these things, sir? A practical session, because now we have the codes, sir. But
Mm-hmm.
when we start applying the codes, what
Mm-hmm.
is happening? We miss something and we are not getting the actual output.
Okay.
So tomorrow's session, could you please train? For the past 3 days, you have given a lot of inputs
Mm-hmm.
how to generate a map.
Mm.
So step by step, if you provide the code, we will just apply the code and see in our systems. No, we all have our systems to work on. Or no, could you please help with that, sir?
Yes, sure. The first man, Lokesh Nayak, has sent me the error that the error in the ST transformation could not find function. So, in explanation part, so see here what is the ST transformation. Here the I am explain this. Uh, ST track and ST transformation. If the error is come, then this will work under which type of your thing. This will work under this library SF. Have you installed library SF, library tidyverse, and library tmap? Have you installed?
Yes, sir. That is in package, right?
Yes. These packages are
Yes, sir.
working in your R.
Yes, sir. Somehow it was working, sir. But I didn't get earlier this code, so I can't try this one, sir.
Please try these things, and beside this, please try to install dplyr package. Okay, rgos
Okay, sir.
package, and try to if you are do all things. So what will you do? First, install and activate all these packages. I am share these things through, then you will not get the error, and then you will
So that I
definitely.
can copy and paste and install, right? In
Yes,
in
yes. If these packages are not available in your R environment, so try to install this through web, or I have already provide you zip packages in a zip format. Go to that folder and select this. Through this, go to the install this package. Go to the package. Go to the install. I have already just click on this zip tar, and I have already lots of packages I have shared with you. So go and select these packages. If not this thing though, so simply write here the name and download install, then automatically downloading is going on. So next, someone asked something. Can you repeat your question, please? Someone asked me. Someone want to this one.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. We were in discussion with the other participant. Actually, sir, yeah, now we have codes and necessary inputs, sir.
Hmm?
So, either in tomorrow's or any other day sessions, could
Hmm.
you provide us the step-by-step code in the chat box so that we
Yes,
copy and
yes.
see.
Okay, okay. I will in a last session, in last day, I will provide all 5 days, step by step. Day one, day two, day 5. I'll provide the all material so that you can find all things in one place. In GIF format, I
That
will.
is okay, sir. One second, sir. Actually, you, for example, we start a new location with you, and then you send us a step-by-step code so that we also see that in our system also the same file format is developed without any error. Like that, if it is given means all these what we have learned will be very much fruitful, sir. Kindly consider.
Yes, sure. So then, if you have any problem, then please send me your data type, which you want to these things. Please write your name and in GIF format. Someone who is this, sir? If get this error, okay, I will. Uh, send you if you have any facing your problem in your own data set. So share with me your data set on my email ID. That's email ID I am share with you. Share to all of you or in a WhatsApp group with your name. So I will try to fix your problem and I will send to the result. So next is sir, we get hello, hello.
Yes, sir.
Yes. So someone asking me something question. Hello, hello, hello. Am I audible?
Yes,
Sir,
sir.
it's
Audible,
me,
sir.
Lokesh Nayak, sir. That
Uh-huh.
the error I have already sent.
Yes,
If
yes,
I get,
yes, I am seeing your error, but
yes, sir.
before someone asking related to data and these things, so I have already shared my uh, email address and this WhatsApp group. So ask me individually for this if you are facing any problem in your own data set. Where is the error has come? I will explain you and try to fix it. So next is that you are facing again some error in the bus dot if you could not find the function pipe plot. Also this function you could not find, so sorry. So these are the problem. If something function is not found in your code, it means that your package is not activated. So try to run these all these packages. So just check these packages are installed in your R environment or not, because the when the function is not activated, or just write handwritten, just remove it and again write the buf and this one, then this will work. Sometimes the copy paste is not working. So if the facing problem, if see all packages are installed successfully, then write just remove it, just copy and paste again, and just suppose that this here this one. So I think bus.dbf, where is this? mm, bus.dbf. Yeah, this one. So you have to first if you have any problem facing this problem in this, so what will you do? Rewrite all these things, and suppose I'm going to run this, see, this will work in my, and this will taking some time. So rewrite all things and check whether your because function is not working, it means that your package is not working properly. So focus on the package and try to reinstall this thing.
Excuse me, sir. Sir,
Yeah.
this is only for San Francisco or any other country also?
So please repeat your question, I cannot hear you.
So you have done all this buffer zone and all around some
150.
schools
Yes.
in San Francisco. But if you want to do for India or any other country, then how will
Yes.
you change the
Yes, you
names?
can change. Yes, you can change everything. I just give you the example because these data are available on the internet. If you have your own
Okay.
data set, then you can do for the own things.
Can
Okay,
you do one example for India, sir, at least?
just India for then what for then I have to prepare the data set for this India. Suppose that in India there is a school, then I have to take the example. Lots of the data are available in internet. So do
That thing we are not able to see, sir. If you are giving all this thing only San Francisco, we will be doing no issues. But when it comes to a particular place like India or any other country,
mm-hmm.
then where we can get that knowledge, sir? Where we can who will guide that?
Just provide me the data of your if you are interested in for buffering in India. Just provide me the data, whatever
No,
data.
you take your own place,
Yes,
sir. Just
yes,
Uttar Pradesh
that's
anything.
the problem. Now, data is not easily available. I have to do field work for this. Suppose that I'm going to a survey. I have a survey team. Okay, a
Mhm.
survey team
Mhm.
provide me the data. Now, my next work is to on desktop and do the analysis for this. So the data is already survey data is available on the for easily I get the San Francisco. But when I will explore the internet, then I will get the for Indian data. So if you are interested
Okay.
in Indian data, so I will show you the tomorrow how Indian data we can create a buffer for in around any place. Okay, I
Okay, sir.
just give you a project, an entire project for a school, then their active business and things. You can
Okay.
you can do suppose that you are
Yeah.
suppose that you are sitting here. Suppose that you are sitting here. This is your place. This is your home. So this is the your point data, and here this something is like this one. Suppose that this is a shop, this is another shop, this is another shop, this is another shop, this is another shop. So you want to do a buffer around 10 kilometer. So it's make a circle around 10 kilometer, and all shops with are 10 kilometer, then this will cover in buffer, and you can easily find out the 10 kilometers are these things. So you can create a data set, but I have provide a project, complete project in this San Francisco. Here is some parking area where the cars are stealing. Here the some area where the things business area, and some river area, and so I just 150-meter area I just do for because 150 area must be calm and cool for school. So I'm doing this project.
Okay, sir. Sir, another one thing. So yesterday class, you were telling exporting the CSV file for coordinates. That
Mm.
time you won't able to get it in the CSV format. You
Yes.
told today's class, I will show you how to export as CSV format. Can you do it, sir?
Export, I have already shown you the
I
how.
mean,
Yes,
no,
import.
just when we are copying that CSV file now in the Excel, we open the Excel file and we are putting some coordinates. In that, how we can able to convert it to CSV, sir?
Uh, I cannot understand. Can you repeat your question,
Now,
please?
yesterday you opened on Excel file.
Mm,
There you input the value of the coordinates.
mhm,
Example, Dr. Suresh has told one coordinate values like -15, something
mhm,
like that.
mhm,
So
mhm,
then you put in the Excel. When
mm.
you copy the Excel and putting in the syntax, it is not accepting, right? Then
Yes,
you told
yes,
it
because
is.
lots of the things are coming with when I'm copy and paste in Excel, then lots of things. But a simple CSV, I have already shown you these things, this type of the CSV file. If you this here, see 2.csv. This is a coordinate CSV file. Just see latitude, longitude, and corresponding this latitude, longitude, a value is a is given, and Dr. Suresh has given me something minus and these things. When I'm copy and paste and make a data frame for this, I am unable to make the data for this because with copy and paste, when I'm fetching this, the lots of the information are coming with it. If we manually write these things and send me the, then just I make a data frame for this and try to plot on this thing and on they convert to the CRS. That's in a special. So I have already show you how to plot this CSV file in your save file and in your GIS platform through R.
Okay, sir. Okay. Just any videos are available that also you can just send us,
Yes,
sir.
I have
Okay.
already uploaded the video today. For yesterday class, I
Yeah.
have
Okay.
already. Please go through. And today is
Okay, sir.
going
Okay.
to also going to live streaming, and volume is just okay with this thing.
Okay, sir. Okay. Thank you, sir.
Okay. Any other question? Please ask.
Sir, if I want to this kind of the data, if I want this kind of the data in future, so where we can get those data, sir? Like how we use USGS data and Sentinel data like this.
Uh, if first that you have to check the data format here. Which I have provided the data here. The first is data is not available in your system. I directly fetch from GitHub. What is the Git and what is the GitHub? Just go to the Google and read about. That data kept there in a zip format. If I'm checking my folder, that's a working directory folder, that is SSP. All data has been downloaded and unzip in this. Okay, so I get these things. I get data in a safe file format. So that data are available on the internet. If you have already downloaded, then make a variable for this and try to directly use these things. But the data size is very huge, and so due to the connectivity and internet issues, I cannot share the all data. So I choose this URL data for showing for working on this for buffer analysis.
Okay, sir.
So lots of the USGS data are working. So suppose that in on USGS data, just connect this URL and use these things. So see this is working or not. If not working, then download and keep in this in your folder. Then connect your data to the. If you're facing any problem, then send me the screenshot and I will try to fix you. And send me your code, then I will try to fix you. Okay. Have you any other
Yes, sir.
question? Please ask. Hello. Siraj sir. Hello. Siraj sir. Hello, Siraj sir. Am I audible? Okay. Now I'm going to stop today here. So thank you so much for joining today class, and we will meet tomorrow at 7:30 same time. So we will do some interesting work on this GIS, and try to recover all these things. So have a nice day and good night.
Thank
Thank
you,
you.
sir. Thank
Thank you.